Hello, how's it going? Today's video, it's going to come across as more of a vlog than a tutorial, because I'm kind of be explaining what I did. So where we were last time is we had multiple objects. We could pass in multiple descriptor sets and draw basically the same mesh and the same texture at different positions and things. And then I tried to modify it to, well, it was a bit of a hack, that's fine. Then I tried to modify it to draw different, or to pass in multiple descriptor sets, and it was just failing and wasn't doing too well. And I wasn't really that happy with the abstractions that I made, so I thought, let's rethink this problem. Let's have a look, see what people on the internet, how they've solved this problem. And I found this website, vkguide.dev, and I think they do an awesome job, a much better job than me, at explaining how to set up like a modern Vulkan engine. As we can see here, this is the most important part. It says here, as opposed to hard coding their rendering loops, this tutorial focuses on like a system, a dynamic system. So that's cool. So what I did is I got in and I downloaded their code, and I'm kind of slow. So the way I learn things is I like code them up. Well, kind of slow because it's a complex system, right? So I code them up by hand, and then the time that it takes to code them up, as I'm going through that, I get a feel for the dependencies between files and the basic flavor of it. So the past 2 days, I think, I've been just obsessively coding, and that was fun because then on day 2, this tutorial uses a memory allocator library, Vulkan memory allocator, VMA, and it just doesn't work with GLFW, and it's an 18,000 line file, so it's a non-trivial error. I couldn't get it to work. So they use SDL in this guide, and I didn't want to do that. So I basically adapted my code in the flavor using the same sort of design patterns and abstractions, but just without the custom memory allocator. Or there's another library they use here called Vulkan Bootstrap, VK Bootstrap, which I just didn't use. So with that out of the way, let's get into what we got here. So I'm going to take this step by step. I actually kind of got it to a point and then saved it and then made another copy so that I would have different points of history. Okay, so let me just maximize this a little bit. That's better. That's much better. Okay, so I followed your advice, by the way, and I set my display to 1080p for recording, and seems to be fixing the issue. So the first thing that I did is I took the main core of the code and I abstracted that into its own header and file, into its own class. So that is good because it gives us, well, it gives us something that we can call. So again, this is just the same code as before, but it's just out in its own header. All the same stuff, just the declarations, and then, sorry, the definitions, anyway, the prototypes, and then the actual implementation is here. We can jump in here and it's the same code that we saw before. Just one note, so you may note that a lot of the includes are being done in the .cpp file compared to the .engine file, and the reason for that is I read on the guide, apparently if you keep your headers as lightweight as possible, that has a big effect on compiling time. I guess that makes sense, right? Because if this is a multi-file project and I only alter a few of the files, well, those few files which were altered will need to be recompiled. However, if they include this file, then its header at least will need to be checked or whatever. And that would include all of the include statements. So for that reason, I tried to get away with the bare minimum of include statements. Even to the point where, right, I'm including my windowing library glfw here. However, I need to declare the class member, if I can find it, to store the window. And the way we do that, the way we get away with it, is we write struct out the front. This is what's called a forward declaration. And this is basically saying, okay, there will be one of these, and it comes down to the implementation. So we go here to the implementation and glfw is included, so that's okay. This just stops the header from squawking at us. So if we run this right now, then yes, it does work. I dialed it back to before the multiple object, just what we had before there. And that's cool. Okay, great. So let's move on to the next stage. I'm going to try to... I'm going to try to bang this out all in one video. I know how annoying it is to try to... Like, we've already done the bootstrap, right? We've done the 101, how to make this, how to make that. Okay. So what I did now is... We can close this. I haven't actually touched these files yet. I just made them in anticipation. Okay. So what I've done is I've created a VK types, Vulkan types header, where I abstracted a few things together, right? So anytime we have a buffer, it's like a combination of a memory and a buffer structure. So those are together. And an image is a combination of an image, its view, and the memory that backs it. So I stuck that together, and then, for instance, if we go down here, okay, for instance, any kind of thing which used an image will now use the whole image structure, and that's okay because, let me find one. Okay, create image view. So here we have create image view. Oh no, sorry. Create image view does use a VK image. The reason for that is swap chain images need image views. However, the memory that backs a swap chain image is automatically created by Vulkan. So didn't really seem to be possible to bind that together. Like the swap chain images, I couldn't make them image structs. I had to keep them. But let's look at transition image layout. So that takes an image. Okay, so anywhere where we needed a VK image, we can access that by going .image. And that is pretty much how I refactored everything. Then if we go to, yeah, like create buffer, for instance. Create buffer will need both the buffer and the buffer memory. So here we have buffer.buffer accessing the VK buffer there. And then, yeah, for instance, when we use the VK device memory, we access the .memory field within the buffer. So that's cool. That's just going through and retyping things. So then that lets us go to the declarations of the things up here. And then for vertex buffer, we can just call that a buffer struct. Same with the uniform buffers and everything. For depth image, we can call that an image. And yeah, we can see all of this. This is cool. This is good. I then created two general cleanup functions, cleanup buffer and cleanup image, and they pretty much do what we would expect. If we jump into those, they just call the standard deallocation functions on the members of the buffer and the image. Okay, cool. So then the next step is I wanted to get textures abstracted out to a different file. Now the funny thing was, coding all this up was actually pretty quick. It was just the process of wrapping my head around the design decisions of the other code base. Okay, so I added a folder called View, and in View I added vktextures.h and .cpp. So then I included all of this. I went to my VK types to the image field, and I added an extra field for MIP levels, because when we load an image, we then generate a MIP map on the image, and we want to store that inside the MIP levels field. Because when we get dynamic rendering going, we want to be generating a sampler for each image, which with its own level of MIP maps, if that makes sense. Okay, cool. So we have this stuff here, and that is pretty much copy pasting the relevant code from the engine. From the engine class. The only thing is we need to use some functions which the engine has access to, like create buffer, upload to memory location. I'll show you that in a second. Create image, transition image layout. So just thinking, it might be an idea to create an extra class to handle these like creation things, because this is memory allocation. So in the vk guide.dev, what they do is they use the Vulkan memory allocator, and they have like an allocator class, which, not an alligator, but an allocator, which handles these functions. And we could kind of approximate that by making our own class, which both this function and the engine have access to, which creates things. But that's not a big deal at this point. This is like a pretty, I don't know, I'm not going to call it a big refactor, but this is going to be an iterative refactor. So this is iteration number 1, where we just get it to work. Speaking of getting it to work, for this reason that we are calling functions within the engine, I had to go to the engine and grab a bunch of those functions that are being called and make them public, just so they could be called. That's not a big deal. That doesn't really affect anything. So what are we doing here? So we take in an engine and a handle to the image, which will be output, and then we pretty much call these functions. Right, and then we have this upload to memory location. So there was a pattern that I was seeing a lot where we do mem copy, and that's pretty much what upload does. So it just handles that, like map memory, the pattern of mapping memory, copying memory, unmapping. It made sense to call that its own thing. So then that function then calls generate MIP maps, and that is just copy pasting the same code, exactly the same code. Okay, so then what else did I do? I've also got clean up image. I've already done that. What am I thinking? Yeah, no, that's fine. So then, where I have create texture images, I have a variable called texture image. I just pass that in as an argument. we dereference the this pointer in order to get a reference. Okay, so I'm not doing a good job of explaining myself here. So this textures.cpp, it takes in what's called a reference to an engine class. So we're passing by reference. Now a reference is it's very much like a pointer. It's actually something called an alias. So long story short, what this means is we pass in an object as if we're passing by value. However, the function gets almost like a pointer, except we can treat it, we're basically passing by reference. So we pretty much get a pointer, except we don't have to treat it like a pointer. We can just do like dot operations instead of the arrow operations, and we can pass that in as if it was an object, but it doesn't affect performance. It's perfectly fine. So when we call this, the word this is the pointer to the class which is running at the time, and then we just put a star out front to dereference that to pass in the value, if that makes sense. But we run this right now. I'm very tired. I've been up late for a long time doing this, and here we have it. It works. Now there is some dip in frame rate. Abstracting things out will typically degrade the performance a little bit, but that comes at the benefit of making the code more readable. Plus, it's also affected by OBS, running a few things at once. But yeah, there it is, it works. That's cool. Okay. So then... the next step is meshes. So again, I pretty much copy pasted the same stuff. I had to include this like hash stuff and the unordered map and everything because I'm defining my struct in the header, including my hashing function that I'm using to test for identical points. Okay, so what I did is I made a structure called a mesh, and I grabbed the vertex buffer and index buffer and I threw them into the mesh structure. So what does a mesh have? A mesh has its raw data, and it also has basically a Vulkan buffer which stores that data. And it has a function to load a model. So what we do is from our engine, we call the load model function to, if I can find it, here we are. So I call my load model, which I've renamed to load models because this is where we're going. We're going to have multiple things. I call it on the statue mesh, so this is now a mesh object. Well, anyway. There. Okay. So I call that loads the raw data in, and it probably would make sense to actually, what do we have? Yeah, so this create vertex buffer, create index buffer. Oh, no. Okay, sorry. No, that is the one. Okay, so that create vertex buffer, for instance, it pretty much works on the statue object. So it would make sense to abstract that in some way. Either put it inside the Vulkan mesh, so we have like statue.create vertex buffer, and that kind of bakes the data, or even put it in the load model function. I don't know. But like I said, this is just the first iteration, and the point is just to get something that works and looks a little bit cleaner than what we had before. Then we'll just keep going on that. Okay, so that is that. And then I think down below I made a cleanup mesh function, which just cleans up the buffers. And that cleanup buffer will destroy the buffer and free the memory. Yeah, so I actually got that mesh stuff done really quickly, like within half an hour. It's literally just copy pasting code. The only thing to, oh, and I'm not sure if I said this before, but so Tiny Object Loader has been shifted here to the place where the work gets done by the object loader, if that makes sense. Need to remember to include this line. Otherwise it won't work, and it will give very cryptic error messages. And if we go to, not that one, we go to textures, I've also moved the stb image.h to this point, because this is the point where the heavy work is being done by the image library. And then we also define the implementation here. So when we can include this image.h as many times as we want, but we only want to define its implementation at one point. And the reason for that is the header has kind of a header guard based on this variable, which ensures that, because this is a reasonably large file, and it's a header only library, which means the core code is actually in the header file. So by defining this variable once at one point, the body of the code is only included at one point, and then everywhere else we have this without this definition, just the prototypes are included. This keeps things as lightweight as possible. But otherwise, again, we'll run this. And yeah, there it is. Works the same way, nothing is broken, but the side effect of all this is we've cleaned up the code a bit, and we've set it into a good framework where we can start looking at properly doing multiple objects and things. So that will be, look, I'm tired, but this is it for now. But in our next video, that will be what we'll be doing. That is what we will be doing. Okay, anyway, that's it for now. And yeah, see you next time. Bye.